Alright, so we are now going to take a look at law of sines. So law of sines can be used to help determine any missing information that you are, not having from your triangle, be it a side length or be it an angle, okay? Now, law of sines is actually a ratio, where you have the ratio of the sine of an angle over its side length is equal to the same ratio, the sine of another angle over its side length. And this, of course, can be extended such that it's used for any of your angles or any of your side lengths. And of course, you can also flip these ratios so that you have your side length over the sine of your angle for all of them. Now, the cool thing with ratios, like all math, you can typically check your answer. Sometimes you might end up with a ratio that is actually not true. And that's where it's the beauty of checking your law of sines ratios, okay? All right, so here are the ratios of law of sines. Let's dive into an example problem. So I'm given this triangle here. I have angle C is 55 degrees. I don't know angle B. I have angle A, and angle A is 30 degrees. The side length I'm given is side length A, 8. Now, some important facts that you actually need to remember about triangles is the fact that their interior angles add up to 180 degrees. So if the question reads, find all the missing parts of the triangle, you could easily do so. So we know total angles is 180. If we subtract 30 degrees and we subtract 55 degrees, this will get us angle B, which ends up being 95 degrees. So we have already actually got one whole part to the missing triangle pieces. We have the missing angle. But now we got to determine our sides. So let's actually take a step back and look at the given information. We're given angle A with side length A, so I know I can use one of these. And I'm given angle C as well as side length C. Again, I can choose to set it up whatever way I want. It's based upon my needs. I'm pretty comfortable with my math, so I know I can do sine of 30 degrees, which is a value actually that you should know, over the side length 8. It's always opposite of one another. I know this is equal to sine of 55 degrees all over a side length that I actually don't know. This is a ratio. This is when I can actually start to use my cross multiplication. So I know that I want to bring C over here, and I'll bring 8 over here by cross multiplying. So I really have C times sine of 30 equals 8 times sine of 55 degrees. My last step is to isolate my variable, so I'm going to divide by sine of 30 degrees. So C is equal to 8 times sine of 55, all divided by sine of 30. Now again, it's very important that you have your calculator in degree mode, because if you don't, it's going to completely mess up all your ratios. After you've typed in all this information, you get that C is approximately 13.1. Like I said before, you can check this. Okay, we can plug it back into our ratios. So the ratio for side A and angle A, so my sine of 30 over 8, if you were to type in this ratio, you would get 16. Now, because I am rounding throughout, when I go to plug it back in, I know that I'm going to be a little bit off, probably by about a tenth, and that's okay, because I'm rounding, as long as it is close enough to my original ratio of 16. So let's plug it back in. Side length of 13.1. Angle C was 55 degrees. Now when I plug this into my calculator, I actually get 15.99, which for me, close enough to 16. I'm pretty content with this ratio. So I know side length C is 13.1. Now the last piece of information I need, of course, is finding side length B. And you can set this up the exact same way as you did before with C. Sine of 30 over 8. That was my A ratio. Angle B had a 95-degree degrees. So sine of 95 is equal to, divided by my missing side length of B. I'm going to do some cross multiplication, and I'm going to isolate my variable, and I'm going to end up getting B is approximately 15.93. My last step, of course, is plugging this back into my ratio like I did before. So sine of 95 all over about 15.93. And again, I know I'm rounding, so this is approximately 15.99. Again, I'm very content with these results. I would say my ratio worked here.